we go. Okay, so we've talked, like I said, a while ago about congruent triangles. We know congruent means that the sides and the angles, everything's exactly the same. That's what congruent means. So they look exactly the same. They're the same size. They're the same shape. Similar. They look the same, but they're going to be different sizes. So they have the same angles, but they don't necessarily have the same sides. So when we think about that, we're going to look at how do we know, what do we know about the triangles? How can we show similarity? There's 3 ways we can do similarity. We can do, let me grab my fun pen here. We could do side, side, side similarity. We could do side, angle, side similarity, or we could do our angle, angle similarity. So there's 3 ways, 3 little shortcuts to show similarity with triangles. And then our common ratio, being able to judge the sides, you know, what's the zoom factor for them. That's what they mean by the common ratio. So I'll just put zoom factor here. Okay. So what we're looking at first on the 6-1, we're going to look at these 2 triangles and we're going to try and decide, are these triangles in fact similar, and is there anything else we know about them? So completing our flow chart, we can see we do have some, well, we can see on our first triangle ABC, we've got a 6, a 7.5, and a 4.5. And our triangle at EFD, DEF, there we go, DEF. We've also got a 6, a 7.5, and a 4.5. So we just started, Logan, so you're good. So we can see, yes, the sides all appear to be the same. Let's make sure that they match up. We can see our hypotenuse here, the 7.5, or appears to be the hypotenuse. There's no right angle marked, so we don't know for sure that this is a right triangle. But it does appear that the biggest side will match, so we can say 7.5 divided by 7.5. That, sure enough, would equal 1. So we want to make sure that our other 3 sides, or other 2 sides, also have a zoom factor or a common ratio of 1. So our biggest side matches together. Our smallest side in one triangle is 4.5. The smallest side in the other triangle is also 4.5. And if we divide those, sure enough, it's going to equal 1. And then that means the last side, the medium side, 6 matches with 6. And yes, that also would divide to make 1. So our ratio is the same all the way through, which means our triangles are definitely similar. So triangle, let's see here. If we go ABC, we would say similar to, and then triangle. So the way I brought this around, I went A, B, C. So I went kind of the medium side through to the small side. So we want to make sure we do the same order over here on the other triangle. So I want to go from the medium side around to the small side. So starting here, started at A, came around. So I need to start at the top of this triangle and come around to the small side. So that'll be F, D, E. So keeping our order the same is very important. That doesn't look like a D, does it? I'm going to erase that and fix it. Let's say here, D. And so then the box underneath, that would be where we put, how do we know that information, or what proves to us that that's why we know these triangles are similar? And that would be our similarity that we see up here. So is it side, 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 angle, side, or angle, angle? And in these triangles, all 3 sides are given. So we're going to use our side, side, side similarity. So then it says, are these triangles also congruent? Well, if they're similar and their ratio is 1, then does that mean they're also congruent? Yes. So that was kind of our definition that we had a while ago, and I think that's actually the top thing on our blue sheet that we'll fill out here in just a little bit, just kind of as a review from first semester, is we know triangles are congruent when they are similar. So are they congruent? Yes, because they are similar with a 1-to-1 ratio, meaning the zoom factor is 1. So maybe even putting that in there. wrote that so condensed. There we go. Okay. So then, not too terrible there. A little review, hopefully. So then it says the symbol, there we go, for similar looks like this. It's just a squiggle. But the symbol for congruent is like this. So we want to know, how are they related? Do they have anything in common? Yeah, totally. Just remembering to actually mark my attendance here for just a second. There we go. There. Holy emails all of a sudden. Okay, so what do we see that these two both have? Well, they both have a squiggle on them, but the congruent symbol also has an equal sign. So they both, so how are they related? So meaning, what do they have in common? Well, they both have this symbol. They're both similar, right? Congruent figures are similar, but congruence takes it a little bit further. Why do you think mathematicians chose the symbol for congruence, what they use? Well, because they're similar, but they're also, take it a little bit further, they're also equal. Oops, also doesn't have two L's. I can do this. Oh my gosh. I was writing up some of the things for the front entrance for, helping people identify where they were supposed to go. And I'm like, does dropping have one P or two? Drop has one P, but does dropping have two P's? I don't remember. It was like my brain completely forgot how to write words over Christmas break. Okay, so there we go. All right, so the shapes are similar. That's why they both have the similar, their squiggle part. And then, but congruent shapes are also equal, not just similar. So they take it a little bit further, which is why we put the equal sign underneath of it. So what Lewis did, they wanted to write a statement that conveys that the triangles are instead congruent, not just similar. So we can see in our flow chart, we wrote that the triangles are similar. So he wants to take it a step further and say, actually, they're congruent. So he wrote triangle CAB. Oops, I got to go a little farther here. So we want to say it's congruent to. So we're going to use the congruent symbol in between. So CAB is congruent to triangle. And now we have to think about what order he went in to be able to make sure that we follow the same order. So CAB, let's take a look here. I'm going to just redraw this really quick. You don't have to. I'm sure it's easier for you guys. So his looks like this. There's his CAB. Yep.
So the squiggly line over the two lines, what does that represent? One more time.
That represents similarity. So triangles that are congruent are similar, but then they also have the extra feature of being equal as well.
Okay. Thank you.
You're welcome. Thank you for asking. Okay, what was the other picture? Looks like FDE, like that. Okay. I'm just redrawing it really quick so that I don't have to scroll back and forth. So this was FDE. This was the 7.5. This was the 6. This was the 4.5. Just so that I can draw on it. So he went CAB. So he's starting here around kind of the hypotenuse and then around the medium side. So we want to make sure that with our second triangle, we do the same thing. So we want to pass the 7.5 and end at the 6. So we're going to go 7.5 around to the 6. So that's going to tell us the order of our letters that we draw in here. So we're going to go E, F, D for that second triangle to make sure that the order stays the same. All right. Not so bad so far. We got a couple of triangles left where we're not even drawing the flow chart. We're just trying to say, are they congruent, yes or no? Do they meet the requirements of congruence? So the next thing, what am I doing? What do I have next on my slide? Let's find out. Oh, this is on the blue sheet. So this is just our requirements. This is kind of a review for how we know if two figures are congruent. And again, I'll post the blue sheet online too. So if you don't have it yet, or if you didn't print it out, or if you don't have it handy right this second, that's okay. No big deal. Like I said, I'll post this all online and you guys will have that. So. Okay, so two figures are congruent if they are similar. So that's our side, 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 angle, side, or angle, angle. So this is just a quick review of what we just talked about. And their side lengths have a common ratio of 1. So a zoom factor of 1 or a 1-to-1 ratio might be a shorter way to say it. So we can see in the triangles that I have there, I've got 10 matches with 10, 9 matches with 9, and 5 matches with 5. They all have the same zoom factor of 1. So that's on the blue sheet again. And if you don't have that blue sheet handy, no big deal. I'll post these online with the blue sheet filled out too, so that you have that and are able to quickly access it. But I'll give you guys a couple minutes for, I know a couple of people are writing it down, so I'm going to give you guys a chance to do that. And then we'll move on. Give you a little quick break. And then the last 4, like I said, we are just going to be looking at, I had to grab mine. I was like, I don't remember what the next part is. And then that's it. Like, well, we just have 4 quick examples and then we're done. Did anybody pick up the, if you picked up the paper copies, you might have noticed the homework packet feels really weird because I was filling paper in the machines. This is totally my fault too. I was filling paper in the machines and wasn't paying attention, and I filled them with cardstock instead of regular paper. So the homework packet, it's not that it's exceptionally big, it's just that it's really heavy. It doesn't fold very easily. Oops, my bad. So yeah, the homework tonight, it's the 611 on page 3. It does run on to page 4 just because there's a couple of like fill in the blank things where they give you a lot of detail. You don't have to rewrite any of this. It's literally just like write 1, 2, 3 in the bubbles, but there's a lot of writing. So it's a multiple choice, a flow chart that should look awfully familiar to the one we just did, and a couple of solving for X problems. So nothing too crazy there. And like I said, I put the answer key on the back for you so that you have that to kind of check and see how you're doing. So lots of review just from first semester. Okay, so I think that gave everybody a good amount of time to get those written down if they were working on that. And let's take a look then. So we've got 4 problems here real quick. We just want to know, are these triangles congruent? So we're trying to figure it out. It says it might be helpful maybe to draw them separately. If they are congruent, we're going to write a congruent statement. PQR, triangle PQR is congruent to triangle XYZ. And if they're not congruent, write not congruent. So just not and then the congruent symbol, just so that you kind of know for sure what's happening here. So they are purposely not drawn to scale. You're going to see that come up. They're not drawn to scale. So they're purposely made to look like they're not equal to make sure that you're checking the aspects of them. Now, we don't do that on quizzes and tests. We draw them as they should look. But you want to just double check the information that you have. So let's take a look. So on our first triangle here, we have, I'm going to redraw it a little bit right here. I'm going to make them a little smaller, but I basically have 2 triangles that look like this. Okay, so I have A, D, B here, and I have D, C, and a B out front again. We can see that they gave us 2 angles, that the angle ABD and CBD. Those angles are equal. They gave us that information. We also can see that we have a right angle here, which means that we would have a right angle on top as well. So we want to know, are the triangles congruent? So the first thing we have to know, are they similar? And our triangles, do we have enough information to say these are similar? So it's kind of like a check mark that we're doing. So we want to know, are they similar? And then do they have a 1-to-1 ratio? Ratio. So those are our two questions that we've got to keep asking ourselves. Come on, there we go. So are they similar, meaning do they have side, 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 or angle, angle? And in this picture, definitely we've got a right angle in both, and they gave us a congruent angle in both. So they are definitely similar. So we can go ahead and say, yep, we've got that. That's the angle, angle similarity. And then do they have a 1-to-1 ratio? Meaning, is there at least one side that we could say is equal in both triangles? And currently we don't have any sides, any numbers on any of the sides. However, we can see in this original picture, both triangles use that side DB. So because they're both using the same side, it's equal to itself. They share that side. So that's enough to give us a 1-to-1 ratio. So because it's shared, it must be equal. And that's going to give us our 1-to-1 ratio. So now we do know, because we met both requirements, the triangles are congruent, and we'll write a congruent statement. So let's see here. If I said ADB, then I would say it's congruent to. So A had nothing marked on the angle. So that means when I come down here, the triangle's reflected. So I need to use angle C and then DB. And there's my congruent statement. And that's it. Boom. So the next one's kind of done the same way. They gave us some more information, or some different kinds of information. But again, we want to know, are they similar? And do they have a 1-to-1 ratio? Those are the two requirements. So first thing, do we have side, 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 side angle, side, or angle, angle on similarity? And I'm just going to draw these separately really quick here. I'm not going to draw them perfectly, but that's okay. So I had D, B, C on the first triangle with some information, and I have B, C, A on the second triangle with some information, something like that. So I just sketched them real quick separately so I could see the information that I have and relabeled them, put the markings in the picture so that I know what I'm dealing with. And so then I can look and see, okay, well, I have a side and an angle, but that's not similar. Side A or SA or AS is not similar. But again, they do both share this line in the middle. So that's another way, another side that I can mark as equal, just like the last one, because it's shared. And so now I have side, angle, side similarity. So I know they're similar. And since they share a side, that side is equal. So I know that I have a 1-to-1 ratio as well. So now I could say again, these triangles are in fact congruent. So they're not just similar by side, angle, side. They're congruent because they also have a 1-to-1 ratio. So DBC, I'm going to go with DBC, starting at the top, around to the congruent angle, and then across the shared side. So I'm going to do the same thing on the bottom. It's reflected, so I'm going to start at A. I need to go across the congruent side and then across the shared side. So I'm going to go A, C, B. And there's my congruent mark, or congruent triangles. Okay. Next ones we have two triangles again. This time we don't have congruent angles given to us, but we do have parallel sides. And that's very important because if the sides are parallel, it means we have some congruent angles. It's been a little bit, But when they kind of switch back like this, zigzag around, we've got some alternate interior angles that are going to be equal. So I know that angle E and angle B are going to match up. And because of this, because of how I have my parallel lines drawn, I could go this way too. So because of I'm connecting from one parallel line to the other parallel line across that transversal in the middle, I know I now have two angles that are definitely equal. So we do have similar triangles. That's that angle-angle similarity. However, I also see, I guess I should say, I have a 6 on one triangle and a 6 on the other triangle. So in theory, that gives me a 1-to-1 ratio. But, big but here, the 6 on the left triangle is between D and C. It's between our double congruent mark and our vertical angle in the middle. The 6 on the right triangle is between the single congruent mark and the vertical angle in the middle. These are not corresponding sides. They don't, yeah, they don't correspond. They don't match. They're not in the same position. Okay, that's what that means. So even though they do have both the same number, they're not in matching places in the triangles. So that means we can't say for sure it's a 1-to-1 ratio. And in fact, actually, the 6 on the right triangle matches with the 4. These ones match. So it's not a 1-to-1 ratio, which means they are not congruent. So that one's kind of tricky. It looks like they should be, but because of where the matching parts go together, they're actually not congruent. All right, and then the last one, we've got some angles we can actually see very clearly. I'm not even going to redraw these ones, kind of like the last one I didn't redraw. I've got that triangle on the left. It's got a double congruent mark in the top and a single congruent mark in the bottom. And then I have my other triangle that looks totally different. However, I have a double congruent angle mark at the top and a single congruent angle mark at the bottom. So when we're checking for similarity, they are similar by angle-angle again. They've got two angles that match. Do they have a shared side? Yes. This side right here, across the bottom, that AB is shared. And it's next to the single congruent angle in both triangles. It's in a matching position. And so that's enough to say that yes, they have a 1-to-1 ratio. Check. That does not look like shared, does it? My writing is terrible. I'm sorry, guys. So because we have all of that, we have enough to say that our triangles are in fact congruent. So triangle, I don't know, let's see here. Let's go dab, right? Oh, I did it wrong. That way. I always do the wrong angle. It's fine. It's much more fun when I'm in person doing that. People are like, wait, did she just? Yes, I did. I did just dab. It's fine. All right, so if I'm going DAB from the top angle down, straight down, and then across the shared side, I'm going to do the same thing over here. I'm going to go CBA. And there's my congruent triangles. And there you go. That's today. Not so terrible. Look at that, a whole minute early. Woohoo.